Hello friends, let's enjoy Biot-Savart's law. In the last video lecture, you have learned about Hens-Christianian or state experiment. Hens-Christianian or state have proved experimentally that a current carrying wire produces magnetic field around it. But the magnitude of the magnetic field is given by Biot-Savart's law. To understand Biot-Savart's law, we are going to take a infinite wires cross section. Let us have a cross section of an infinite wire. Let current is flowing from x to y direction. This is direction of current. Let us take a elementary length dl here. This is the dl elementary length here. Let us draw a tangent on the elementary length. So let us draw a tangent on the elementary length. This is the extension of tangent. This is the tangent along this. This is the tangent. So you have the tangent here. Suppose we require to find here at point P what is the magnetic field. Then from O, this point is O to P is distance R, and this to this end is the length dl. This is the small elementary length which you have taken. Now this is R, so this tangent and R make an angle theta. Then according to Biot-Savart, magnetic field produced at this point dB, a small amount of magnetic field dB, is proportional to the current I is the current I, dB is proportional to elementary length dl, that is dl, dB is proportional to sine theta, where theta is the angle between the tangent and R, that is dl and R, where theta is angle between dl and R, and you have dB is proportional to 1 by R square. So magnetic field at point P depends on 4 quantities, that is current I, length dl, sine of angle theta between dl and R, and inversely proportional to the distance between tangent to the point where you are going to find the magnetic field. Combining this, you get dB is proportional to I dl sine theta upon R square. So now this, when you remove this proportionality sign, then you will write the next line, dB is equals to mu naught upon 4 pi I dl sine theta upon R square, where mu naught is equals to 4 pi 10 to the power minus 7 Tesla meter per ampere. SI unit of magnetic field is Tesla. Tesla symbolized by T. So here it is Tesla, here it is meter square, and it meter cancel, here it become meter, and this is ampere. So move this meter this side and this ampere this side. So you have mu naught equals to Tesla meter per ampere. This mu naught is known as absolute permeability of free space. Now if you want to write this equation number 1 in vector form, then you have to multiply the numerator and denominator of RHS by R. So we can write here dB is equals to mu naught upon 4 pi I dl R sine theta upon R cube. We have multiplied the numerator and denominator by R. So here you can write dB in vector form is equals to mu naught upon 4 pi I dl cross r vector divided by r cube. This is the vector form of Biot-Savart's law. Thus you have understand the vector form. Here you are seeing that dl cross r is a cross product of two vectors. So the direction of magnetic field at point dp is obtained by dl cross r, that is right hand screw rule. So direction of db is given by right hand screw rule of dl cross r. Now let us apply it. Put your right hand on dl. This is the length of dl. Put it like this and put your this forefinger, curl the forefinger towards r. So put it and curl it. What you are saying, that the thumb is inside the board, so the magnetic field is perpendicular and inward to the plane of paper. So here you are seeing that magnetic field is inside the board. So inside is indicated by cross. So magnetic field dB is perpendicular inward to the plane of paper. So you can find the direction of dB by cross product. If you have another diagram that the currents are moving from upward to downward side, like this is a diagram, suppose I am giving the same diagram, current is moving from this side and you have taken a current element here, and this is again a point dB, this is r. Now you have to find the length is dl here, the length is dl here, elementary length. Current is moving from upward to downward direction. Now here dl is the direction of the current. So in this situation you have to put your right hand on dl and move towards x. So dl is this direction, so this is the angle now. So put your right hand here and move towards r, curl it. So the thumb is outward from the plane of paper. This means that the direction is perpendicular, normal, outward from the plane of paper. So observe the diagram and use the right hand screw rule. Thus you understand what is Biot-Savart's law. Now you are going to solve numerical based on Biot-Savart's law. Numerical. Numerical number 1. In this first numerical, I am taking an axis. This is an axis, this is x-axis, this is y-axis. Let us have a elementary length on the origin. Let us have a wire of elementary length on the origin. This wire is of dl, and dl equals to delta x I cap. This is the vector delta l. And current is moving towards x-axis I, which magnitude is 10 ampere, where delta x, that is length from this end to this end, is equals to 1 centimeter. Let it be 1 centimeter. So what will be the, here we required the magnetic field, here we required dB magnetic field. The distance from origin to this point P, from O to P, is r, and r is equal to 0.5 centimeter. Let it be 0.5 centimeter. Now you have to find magnetic field at point dB. So we are going to use Biot-Savart's law. So according to Biot-Savart's law, dB is equals to mu naught upon 4 pi I dl sine. You are seeing that this is the length dl, this is dl, and this is r. So r and dl are making angle here 90 degree. So you write I dl sine 90 degree upon r square. Sine 90 is 1. So you have mu naught upon 4 pi I dl upon r square. Now put the values. So the value of mu naught by 4 pi is 10 to the power minus 7. I is 10 ampere here, and dl, here dl dl is equals to delta L, which is equals to delta x, and delta x is 1 centimeter, 10 to the power minus 2 meter. So you have dl is equals to 10 to the power minus 2. What about r? R is 0.5 centimeter. This means that 0.5 into 10 to the power minus 2 whole square. Now solve it. When you solve it, you have 10 to the power minus 7, 10 to the power here minus 2, this is 10 to the power minus 9 and 10 to the power 1. So 10 to the power minus 8 on the numerator side. On the denominator side, 5 square is 25 and point will eliminated. It become 10 to the power minus 2, minus 1 to the power minus 3 into 2, 10 to the power minus 6. So 1 upon 25 is equal to 0.04 into 10 to the power. When it moved to upside, you have minus 8 and minus 6, so you have minus 2. So you can write 4 into 10 to the power minus 4. This is, you have find dB magnetic field. So it is in Tesla. So your answer is dB equals to 4 into 10 to the power minus 4 Tesla. Let us see another question, a very nice question for you. This is a second question. In this second question, suppose we are taking a circle and just we are cutting an arc of 90 degree from that and remove it, and remaining parts we will join with a wire. Let us see this. This means that if it is a circle, then in this circle we have an arc. So it is we have taking an arc here. Let this is 90 degree. Remaining part is removed. So this is the radius. This is radius, dotted line. So here this line is outside, this is outside. Let current I enter from this side and it move a circular path and leave from this side. So what will be the magnetic field at point O at center? Here what will be the magnetic field B? You have to find it. Here radius is R is equals to 3 centimeter and let the current is equals to 10 ampere. So you have to find magnetic field due to A, B, C arc. Okay. Now for this we are going to use Biot-Savart's law here. So according to Biot-Savart's law, dB is equals to mu naught upon 4 pi I dl sine 90 degree upon r square. Where sine, how sine 90 come this side? For that, here let us dotted line here. This is the radius vector said to be r. Let us have a tangent here. Tangent. This tangent give you the length dl. So dl and r make angle of 90 degree here. So cos sine 90 is written from this side. This is the 90 degree angle. Clear? Now this give you mu naught upon 4 pi I dl upon r square. Let A, B, C equals to L. Length from A to C is L. So you have to find magnetic field due to length L. So what you will do? You will integrate it. So therefore integrating dB from 0 to B is equals to mu naught upon 4 pi I upon r square integration dl 0 to L. Integration of dl 0 to L is L. So you have B is equals to mu naught upon 4 pi I L upon r square. Let this be equation number 1. Now we require the length L. So to calculate L, we know theta is equals to ABC arc length divided by radius r, and ABC arc length is L upon r here. Now what is this angle theta? This is the angle theta here. What is the angle theta? This is 360 minus 90 degree. So this angle theta is 360 degree minus 90 degree, which is equals to L upon r. Now 360 minus 90 is 270. So you have 270 degree is equals to L upon r. 270 degree can be converted into radian, which is equals to 3 pi upon 2. So this is equals to 3 pi upon 2, which is equals to L upon R. This means that L is equals to 3 pi R upon 2. Here we get the value of L and here we get the value of B. This is equation number 2. Put equation 2 in equation 1. So let us place equation 2 in equation 1. Put equation 2 in equation 1. What you get? You get B is equals to mu naught upon 4 pi I upon R square. What is L here? L is 3 pi R by 2. So write here 3 pi R by 2. Now let us solve this. When you solve this R will be cancelled out, and this mu naught by 4 pi is 10 to the power minus 7. So no need to cancel this pi. So it is 10 to the power minus 7. What is I? I is 10 ampere here. Put here 10 ampere. 3 value of pi is 3.14. What is R here? 3 centimeter. This means that 3 10 to the power minus 2 meter, and here it is 2. So cancel this 3. Now what will be the powers here? Here 10 to the power minus 2, when it move to upside become plus 2. Here 10 to the power 1, 1 plus 2 is 3, plus 3 minus 7 is equals to 10 to the power minus 4. So 3.14 upon 2, 10 to the power minus 4 Tesla. Divide it, 2, 1, here you have 1, 11, so you have 5, 7. So 1.57, 10 to the power minus 4 Tesla. This is B, magnetic field. Now you require to find the direction of magnetic field here. So direction of magnetic field can be found by dl cross r. Direction of magnetic field is dl cross r. So put your hand on this dl palm and curl your forefingers towards r. What you are finding? The thumb is inside the board. This means that the magnetic field is inside the board. So here you have the magnetic field like a cross sign. So direction of B is dl cross r, which is cross. That is, it is perpendicular to the plane of paper. Thus you have learned a very nice numerical. Let us see a third numerical based on Biot-Savart's law. For third numerical, it is a very nice numerical, many times come in many examination, competitive examinations. So must go through this numerical also. This is a concept clearing numerical. For this numerical, I am taking a circle here. Let us take 2 points, point 1, point 2. Let us take a wire outside and connect it with a battery source and a key. Now here is the battery source. When the key is on, what will be the magnetic field be? Here you have to find it. You have to find magnetic field at the center. So the question says that we have a circular wire. We connect the circular wire with 2 ends and a battery source and a key. When the switch is on, then what is the magnetic field at the center? Let us work out for this. Let current I is coming from this side. It is divided into 2 parts here. This is said to be current I1. This is said to be current I2. So I1 will move from point A, this is X, and this is, since I have written here B, so let us change the word, okay. Let us point P, it moved to X and it comes to this point, this is Q, and here it is Y. So current at PXQ is I1 and current at PYQ is I2. We have to find magnetic field at this point center due to those 2 currents wire. We know magnetic field at center due to length L at center due to length L is B is equals to mu naught by 4 pi I L upon R square. You have seen from the last numerical that B equals to mu naught by 4 pi I L by R square. So you have B1 is equals to mu naught upon 4 pi I1, and let PXQ length is L1 and PYQ length is L2. So this is L1 upon R square, where R is the radius. This is equation number 1. And B2 is equals to mu naught upon 4 pi I2 L2 upon R square. This is equation number 2. Thus we have taken 2 equations. Now since current is entering from this side and leaving from Q side, so this side and this side, both the end will get the same potential because they are in parallel combination. So as they are in parallel combination, as PXQ and PYQ are in parallel, so voltage for PXQ is equals to voltage for PYQ. Since here PXQ is having current I1, so for simplicity I am writing here V1 and this is V2 voltage. Now let us solve it. According to Ohm's law, V equals to IR. So you have I1 R1 is equals to I2 R2. Now you know that R is equals to rho L upon A. You know that R equals to rho L upon A. So put the value here. This is I1. This is rho constant L1 upon area A1. This is I2 rho L2 upon area A2. Since you know that A1 is equals to A2, because the wire have the uniform cross section, so this A1 and A2 will cancel out and rho will cancel out. So we get I1 L1 equals to I2 L2, equation number 3. So in equation number 1, you are seeing that B1 equals to mu naught 4 pi I1 L1 upon R square. Equation number 2, you are seeing mu naught 4 pi I2 L2 upon R square. And equation number 3 give you I1 L1 equals to I2 L2. This means that these two quantities are same. So from equation 1, 2 and 3, we conclude that magnetic field B1 and B2 are same. So from equation 1, 2 and 3, we have magnetic field B1 equals to B2. Thus you can say that B1 minus B2 is equal to 0. That is, magnetic field at the center of the circle is 0. So that is what we write. We write thus magnetic field at the center of circle is ZDRO 0. Thus you have learned Biot-Savart law and you have seen how we are going to solve different type of numericals based on Biot-Savart law. You are enjoying physics? Do like, share and subscribe my channel. It is Physics Gold Ravi Kumar. Thank you.